boxes. Now, if you would like, you will notice I filled in the rest of the week for you. So, it would make the rest of your week easier if you just write that stuff in now. So tomorrow we'll be moving on. And actually, we'll probably potentially get into 223 today. So if you want to go ahead and work on that practice assignment tonight, you can get ahead on homework. Here's my advice. Do tomorrow's homework today. Do Friday's homework tomorrow.
Mr. Smith, please stop by the office. Mr. Smith, please stop by the office.
He's not here,
Yeah,
right?
he's not here today. No, he's not. Yeah, 'cause I'm
Is he on that observation cycle thing? Is that what he's on?
Hi, you've reached the office.
Hey, Colin's not here.
Ah, all right.
Yeah, he's at a PD. I have his sub here if you'd like me to send his guest teacher down.
No, not what we need. Thank
Okay, yep. So, I would do that so that you don't have homework over the weekend. Now, remember, a Friday homework isn't really due Monday. It's due by Tuesday, so you never really have to do work over the weekend. But if you just work ahead, since we don't have a new assignment tonight, you could get ahead and have no homework over the weekend. So, we are going to dive in right where we ended yesterday, right after Cecil's typewriter. So, go ahead and open to from 245, or forget what student page you guys are on. Anyone know what page this is?
He spelled my own last name wrong.
Should be like 89 or 90. 89. So page 89. Please have our toolkits or our math journal out, whatever you're taking notes in right now. If your math journal fills up for chapter 2, or if your toolkit fills up in chapter 2, please don't go to chapter 3. Please switch into your math journal. You don't want to fill up your entire toolkit only like a third of the way into the year. That would be bad. So then, yeah, let's just talk for a minute. I was going to have your guys' groups read, but that's a lot of reading. So, to remind us what we did in 44, if you look at yesterday's notes, we were dealing with drawing on the tightrope, right? And then we did not draw part D because our tightrope wasn't long enough. But if we tried to draw 8 plus a negative 5, or 8 plus a 5, we talked yesterday about how these moves would be different, right? One goes one direction, the other goes the other direction. That's right where our conversation ended. So, we know that these are opposite values. We talked about additive inverses. We talked about all that. The new word that we're going to bring in, absolute value. So, up on the TV, if you want the real super duper formal definition, is absolute value. Or, if you want the easy definition, now remember what needs to go in our journal or toolkit every day. Date and topic. So your header, right? So today's 9/27. So please make sure you have that down. And we are still in 222 today. So you could just write 222 like continued. Absolute value. We want to write this definition in our notes, please. Anyone ever heard this before in elementary? Any 6th grade teachers teach it to you? Anyone know how to describe it? How to easily talk about it? Matt, was that?
I don't know how.
Okay.
The distance from 0?
It is the distance from 0. That's it. That's all you have to write if you spell from correctly, which I'm struggling with. Distance from 0. So, if we're talking about Cecil, let's imagine there's a platform and then a tightrope both directions. Bless you. Or you can think of one giant tightrope with a platform in the middle. If that middle is his 0 point, like we think about number line, he can move back and forth across and away from that platform. But eventually, if he's not on the platform, he is some distance away from it. Whether he's to the left or to the right doesn't matter. He only cares about how far away from it he has to go to get back. So, my nickname for absolute value, if you would like to write this down, it is optional, is the attitude adjuster. The attitude adjuster takes everything that walks through it and makes it positive. Now this might be the rule that some of you have heard for absolute value. We don't really like you to just memorize that rule, right? But back in the olden days, we might have just said, absolute value, just memorize whatever's in it, make it positive. But the issue is that kind of confuses people sometimes because we have to do what is inside of the absolute value before we make it positive. And you're probably like, what? Absolute values work just like parentheses or brackets or any other grouping symbol. So I'm going to let you guys play with these for a minute. But with A through D, you got to solve inside the brackets, inside those bars, before you move out. And we do call them bars, absolute value bars. They're just like jail bars, kind of. Do I not have that poster hung up right now?
You mean that one? Like the one that's near the coffee?
Ah, green one. So if you forget about absolute value, green poster over there. So like jail bars, those negative values, when they get let out of jail, quote unquote, they become positive. They're happy, right? So in A, I'll help you guys out with this one, and then I will release you for the other ones. Inside the absolute value bars, we have two bad guys, right? Negative 20, negative 5.3, and they are joining forces. So what are we going to have when they join forces? We have hands, right? Yeah, Patrick?
25.3.
Good guy.
Oh, no. A
A
negative 25.
negative 25.3. Then the absolute value bars. I'm trying to think of what movie they like zap people and make them all happy and positive, whatever. Whatever you want to think about, it takes the number and says, hey, negative 25.3, how far away from 0 are you? And distance can't be negative. You can't go a negative 3 feet. Like, even if I go 3 feet in a positive direction and then 3 feet in a negative direction, that's direction. That's not distance. You can't travel negative. Like going back in time. It doesn't make sense. So this then just becomes a positive 25.3, and those bars disappear when we make it positive.
Wait, is this question 45?
It is. It is question 45 from yesterday, yeah. So as your groups, go ahead and work through B, C, and D as teams. Gonna go make sure everything's cool. I think it's, yeah, I'm just checking. I used to guess that.
Oh, guys, are we supposed to be working? Yes. That's why I said.
Wait, are we supposed to be writing right now?
Yeah, we're supposed to be doing B and C.
So work on B, C, D.
Okay.
You guys know what's up on as your teams.
Okay.
Who else was on
Five. Plus
You guys need to send
7.10 is
raise hand and all the other groups.
people.
If your team finishes 45, you can move on to 46, and we probably only give you guys 2 more minutes to work.
Yeah. It's 89.
Is it inside the absolute value? No, the absolute value doesn't affect it. So the absolute value affects what's inside of it. There, as you work out. Because the negative's not inside the absolute value. That's why that number gets let out of jail and then becomes negative. Sad, right? He went back to his old ways.
We went on the
Yeah.
wrong page. I'm just giving.
Right, so does absolute value. But also, we don't apply the absolute value to the 0, we apply it to the sum. What's the sum of 0 and negative 3?
Oh, yeah.
Negative 3, so then we apply the absolute value to that.
No. No, I thought Penelope was saying that she got D. She got 3 on D. She got neutral. Okay. Did we do the red sandpaper yesterday?
No. She only got 400 grit. That was the best I had.
Why you need this?
For my current woodworking project, I made these. These weren't super nice though. But now I'm making a coffee table right now. Alright, I think most of us are at that point. I'm going to go ahead and erase this one since we did it together. And I need a little bit more space. So for B, Francesco, what did you guys do with B? What do you think?
We added 47, 45, 7, and
Okay, what'd you get? When you added those inside the absolute value, what'd you get for the sum? 52.7. Then we apply the absolute value. What does that become? I like asking those questions when you're like, is Mr. Hudson off his rocker? Yeah, so if I have to make something positive and it already is, it doesn't do anything. It doesn't change anything. So in C, this is a bit different though. In C, Delaney's sick. Zoe, in C, what'd you guys do? So what was that? 89. So nothing changes when I add those numbers together. That was the only thing I did. Then, this is where it gets kind of weird. What happens then? What's the absolute value bars due to the 89? Makes it positive. It already is, so it stays positive. Then, what's this do? Makes the whole thing negative. This ends up being negative 89. Even though there's an absolute value involved, the negative is outside the absolute value. So, working from the inside to the outside, that negative happens last. Are you okay? You have a nosebleed?
No.
Okay, just checking. Sometimes with the dry air in here, people need to go to the office for nosebleeds. All right, and D. Eleanor. For D. Now this is weird. We have 0 inside there to start. So what did you guys do?
0 minus 3 was negative 3.
Yeah, so they changed this addition into thinking that it's really like 0 minus 3. Because if I add in 3 negative tiles, it's the same as taking away 3 positives. And that'll make a little bit more sense once we start playing more with tiles. Okay, so what is that?
Negative 3.
Negative 3. So if nothing else changes and I just do the inside, I have the negative or the opposite of the absolute value of negative 3. What's that become?
3.
So, in the end, it's 3.
Yeah.
Liam?
The negative 3 in the absolute value bar turns to a positive 3, but then you have that negative sign and that makes it negative.
That negative becomes positive because of the absolute value bars. But this negative is still there. So, your final answer for that one is negative 3. Not every problem involving absolute value comes out to be positive. Even though absolute value makes things positive, that's not the only thing going on there. There are multiple operations happening. Any questions on any of those? All right, check out 46 with your teams. You guys, I believe, can go ahead and read through that and start to try to figure it out.
Perseus' name is Act. He starts at point A on the left of his tightrope, walks on the tightrope, turns around sometimes many times, and then ends up back at point A on the left end of his tightrope. A. Work with your team to write at least 3 expressions that show how Cecil can move his dual start and end at point A.
So he decides to go back to the beginning. He starts his act, freaks out, goes back. What you're trying to do is write expressions that show that. So to make sure we're all on the same page with understanding, he's ending the same place where he started. So he does a bunch of stuff, but ends up back at the beginning. That's what you're trying to write expressions out for. Then this is the big challenge. Oh yeah. Make sure you have one with 8 numbers. You don't even know how long the tightrope is now. They keep changing it. Maybe he can't even see the end of the tightrope, and that's why he decides to turn around.
Wait, wasn't he blindfolded?
Maybe, sure. Then he definitely can't see the end of the tightrope. Man, I would not do that. I would do a tightrope, but not blindfolded. I would totally do a slackline. You guys saw the slackline video, right?
Yeah.
Because I was gone. If I buy a slackline, I'll bring it to Phoenix at some point. You what? Yeah. Well, I would just, because I have my climbing gear, I would attach to the slackline. And if you fall, like if you have it high up, and if you fall, then you just like caught with your arms. So Cecil's gonna start, do some stuff, and end up back exactly where he started. Right? Hopefully he doesn't actually go under the tightrope, but who knows? Maybe it's very creative. He's swimming around from it or something. Who can give me expressions? I'll take volunteers here. Ways that we can do some stuff and end up actually getting back exactly where we started. Mr. Curry?
4 times 2 minus 8.
So you're saying, not highlighter, come on. 4 moves of 2, and then I'm actually going to say plus a move back of 8, because I like addition better. I'd rather say we're going to add another move on. I like it. What do you think, Ella?
0 plus 3 plus 3 minus 3 plus 3.
Hold on, whoa, hold on. I realize I'm going to need more screen. All right, 0 plus 3.
Plus 3 minus 3 plus 3 minus 3 minus 3.
So I love that you guys are already thinking like, well, if I add a move in the negative direction, it's a minus really kind of because I'm adding or subtracting. Remember, if we're adding to his routine, we really first want to think about it as addition. Then we can make it subtraction. So remember, if we are subtracting, we're adding a move in the negative direction. 1, 2, 3, 1, 2, 3. Yeah, there are as many positives as negatives. And was that the one with 8? No, that has 7 numbers. It challenged us to make one with 8 numbers to get us back to the beginning. Anybody else before I go to Patrick? I don't want to have to start paying him for being a teacher's assistant. Patrick?
2 plus 2 plus 2 plus 2
Plus a negative 16. So, if you were to visualize this, we got Cecil blindfolded, right? And he's like, all right, 2 and 2. He does this for a while, right? He does 8 of these moves, I'm guessing. And then, like a bird hits him in the head or something, he's like, nope! And he gets, right? So we end up back at 0. But, if we think about how far, now this is a dangerous question, how far he actually traveled. You want to tell me how far he actually traveled? Not where he ended, not the sum, but how far he traveled. Alex?
32.
Why 32?
Because he went 16 forward and he went 16 backwards.
We went 16 that way, then 16 this way. So if you talk about travel, that would be 32. But when we talk about absolute value, where do we end up? Where do we sum when everything is said and done? Well, I ended up right where I started. If nobody saw it, it was like nothing happened. Very good. Moving on. For 47, Sally lives in North Dakota. Don't know if anyone is thinking about getting out of Ohio, but there are plenty of other places to live, some of which are much colder. So, winter temperatures often below 0 in North Dakota. We've been there a little bit recently. One day, well, not like recent, but in recent winters. One day the thermometer read 10 degrees below 0, but it rapidly rose 15 degrees in 1 hour. I think that's pretty important. As a warm front moved in, then it dropped 15 as night fell. So, can you write this out and show or justify or whatever what the final temperature reading is when Sally goes to bed, or whatever we want to say, the end of the scenario is. Cooking dinner, going to bed, whatever, as night fell. So try that. If you get done with that, move on to 48. I'll give you guys like 4 minutes. That's probably good. Matt likes that. So you more the health and wellness guy, or you what's your forte? I'm looking for subs for the future. Okay. Okay, very good.
You've added 15 because it rather than those. Okay, so if it's a 10, negative 10, and then pick 1 or add 15, add negative 15, it's a 10, negative 10 plus negative 15 is
Where I don't have to take all the time. But still, I get that student out. Yeah.
Oh, add 15 and you go up.
Some days I
From
really
negative 10. Wait, it ends at negative 10. I would have made the same sentence. It goes, it ends at negative 10 because you go up 15, but then you go right back. Plus negative 15. Oh, and you go right back. Is, 5. Huh? Negative 5.
Hey, Marvin.
Okay.
Marvin.
Yeah. So, was it negative 10? Yeah, plus negative 15 is 5. Yeah. So then you go right back 15. Yeah. Yeah. Minus 15. Because you just you go up 15 and then you just go right back 15. Oh, it's negative 10. 15 minus 15 is 0. Yeah, but 15 minus 5 is 10. Yeah, the answer is negative 10. Negative 10 minus negative 15.
About a minute left, guys.
I'm going to draw a diagram. Yes, that's what
You're down on 47, move on to 48.
Okay, so we'll just draw a number line.
That's what I was going to do.
Below 0. Rose 15 degrees. Okay, I don't know what I do.
What do we think about when you're given a problem involving temperature? This is not a trick question. This is not even a math question. What do you think about when given a problem involving temperature? Grant? So if you start trying to think like I'm going to visualize this problem, Ella? Okay. Not really. It's going to cool down. How do we read temperature? I can't believe I haven't asked this many questions. What is the tool we use? A thermometer. So when I see temperature, I think thermometer. Now, old school thermometers just look like this. Celsius, Fahrenheit, temperature. Some are dials that rotate, whatever. These are the good not magnesium. I'm trying to remember what's in it. Something. Some chemical that you don't want to put in your mouth, yet we filled thermometers with them and said, stick this in your mouth. If they break, it's very bad. But just don't break the thermometer and you're safe. Mercury. That's what it is. Mercury is the cool, like it's metal, so it comes back together. It's attractive to itself. So you spill it, it'll try to come back to itself. It's really sweet. It has like a mind of its own. So if we were 10 degrees below zero, let's choose a 0 point. So go ahead and model this in your notes. If you did not draw a picture, draw a thermometer. Real easy. Just a little bulb on the bottom where the liquid would stay, the magnesium. And then it's narrow because the magnesium changes size. Ask Kabila if you want explanation of how thermometers work. But it changes size as the temperature changes, and that's how it goes through the tube. If it's 10 degrees below zero, is that a positive or a negative value? Negative. Right, so that's going to be down here. What I don't know how my thermometer's ranged, but I'll just say that this is my negative 10. Then it rose 15 degrees in 1 hour. Does the 1 hour matter? No. That 1 hour is a distractor. Identify what matters and what doesn't. That 1 hour does not matter in this problem. And then it dropped 15 as night fell. So if I were to draw this, I'd really think, okay, it went up 15, went down 15. So, Penelope, where do we end up?
After you add 15.
After everything's said and done.
Oh, negative 10.
Wait, I thought we started there.
Well, I mean,
Hey, Pettigrew, you're playing from my computer. Give me 2 seconds. That's really funny. Oh, she's in the family room. She just took over my Spotify and is playing it from the family room. That's really funny. Now it should kick it over to her computer since I turned it off on mine. That's separate. That's not the same thing. So wait, if we were to write this out in an expression, right? I want to merge all this into what happened. How would I write this? Mathematical expression. Annika, what do you think? Your card's out. Couldn't do that one. Did I? You're close. Negative 10. We like to put negatives in parentheses just to kind of group it by itself. Then we add 15, and then, yeah, we add a drop of 15, and these are called what? Say it louder. Additive inverses or opposites. Perfect. They sum to 0, and we really just have negative 10. Move on to 48 with your teams. I don't really want to preface it, so just dive in, and then we'll come back together again in a couple minutes.
Gina was working on the previous problems and she had a new idea. Look, she listed. I did. Okay. I can use these ideas to add large integers quicker than even picking up a pencil. She wrote down each of the following expressions and calculated each answer in less than 5 seconds. Talk with your team about how she could have done this.
Nope. No calculator needed. Yeah. I bet you could do it even faster than that.
So basically, what you're trying to do is
What you're trying to do is what? Yes. You're trying to see what addition is necessary or what's unnecessary. So if we look at these problems here, we're saying what is actually necessary to do and what do I not need to do. So if I just start trying to work through this left to right, I'm going to think I need to add that and then add that negative. But if I look at that slightly differently, what if you like zoom out, look at the whole problem, and then decide what can be done to make things easier? What in A can be done to make life easier? Why? So really, be careful saying take away. We can like join them up or put them together or combine them or whatever we want to say, but take away is kind of a dangerous word to use. So I would almost, if I wrote that out, draw like an arrow connecting them and put 0 above it, and then what are we left with? Just 212.72. So I would connect those, show that they're additive inverses somehow, or we could write it in a different order and put the additive inverses right next to each other. Remember guys, addition is commutative, which means we can move, we got it working. We can move anything we want as long as we keep adding between them. So A, we could, if we wanted to, rewrite it 583.6 plus the negative 583.6, then plus that 212.72. I could mess with her.
Yeah, do it.
No, because it's her lesson. Maybe at the end of class.
It's not. It's just them listening to music.
I know, but it's her lesson. So, now wait. So A is pretty easy. Who can explain why A is pretty easy? B gets tougher. Alan, why is A pretty easy?
Because 583.6 and negative 583.6 are additive inverses.
So that means?
That you're left with 212.6.
Yeah, so the one thing you didn't say, I know you thought it, but that means these equal 0.
Yeah.
So therefore, this is just my answer. Now, B, we have to get a bit more strategic and think a bit more. This is like what we did yesterday. Remember our, I need to look up these names, the Power Rangers, when they all come together, Megatron or whatever his name is, we can join up forces and we can break apart our forces, but they keep their signs, right? If they're positive, they keep their positive. If they're negative, they keep their negative. So in B, now Patrick, I see your hand, but I'm curious. Renard, have you guys talked about B yet? Give you guys 2 more minutes. Try to, with your groups, get through B and C, and if you're done with those, move on to 49. Well, let's give you a couple more minutes to try to deal with B and C. There's a way to really easily solve B, but it involves breaking up the stronger force here.
Oh my God.
We're trying to make zeros. Alright, we're pretty darn quiet, which makes me nervous, so let's just have a conversation. Which is my stronger force here? The positive or the negative? So if these guys go into battle, who's going to win? Nathan, what do you think? Who's the stronger force? Positive or negative? The positive, right? 313 is a bigger force than 300, even ignoring the fraction amount. So if I want to try to make zeros, find additive inverses, how can I do that? Patrick?
I thought of it as like taking away like 611's that picture. Well, it's not a picture, but put it aside.
Yeah.
And I broke up 313, so I just took away 13 from 300 and made it even. And then
How'd you know that? Or why did you choose that?
Because I thought it would be easier to do 300 minus 300, so I'm left with 13 and 611.
What we're wondering, what can make my weaker power, my weaker force, whatever, turn to 0? Well, it's a negative 300, so we would need, what's the additive inverse to negative 300? Positive 300. So if we want that, this is why Patrick said I broke this up into 300 and 13 611s. Now these make 0. And what are we left with? 13 and 611s. That's it. Any questions? C, we can do the same thing, but it's a little bit tougher. So we're running out of time. Let's go over C together here. So I'm just going to delete this really quickly, or move it out of the way at least. Which is the stronger force in C? Yeah, Ella?
212.
212, right? It is further away from 0. So I'm going to rewrite this thing. If you have not done this, or even if you have, you might want to rewrite this with us. 212 plus negative 150.75. So we want to make zeros. So I need to figure out what will combine with my weaker force, that evil negative 150.75, to make 0. What's the additive inverse of negative 150.75? Yeah, it's opposite. I'm trying to get you guys to figure out, quit saying the numbers, just say it's opposite. So, positive, right? So write that down in here. We're going to pull that piece from the positive. Here's where I'm okay if you want to grab calculators. I prefer that you not. But if you want to, I get it. But the question becomes, if we borrow or take away that much from my positive force, how much is still left? Forget about the 0.75 for a minute. What if it was just 150? Well, then we have 50, 62 left over, right? Now take away the 0.75. 61.25. And that would be our answer. We will move on to the next lesson tomorrow. Have a wonderful day, guys. Try to work ahead on your homework if you can. You prefer to not have homework. Here, if you want to see what I'm talking about, I'll try it. I'm going to pause my video first, though.